All right, lesson 3.8, slopes of parallel and perpendicular lines. If two non-vertical lines are parallel, then their slopes are equal. Two non-vertical meaning they have a slope. Vertical lines have no slope, they are, excuse me, they are undefined. Their slopes are undefined. So if the slopes of two distinct non-vertical lines are equal, then the lines are parallel. So if we take a look at two lines, in the equations of a line, if their slopes are the same, then the lines are parallel. Any two vertical or any two horizontal lines are parallel. So let's take a look at these two lines. Are line 1 and line 2 parallel? Now we can do this a couple ways. We can count to find our slope, or we can use our slope equation to find our slope. So in order to see if our two lines are parallel, we need to compare their slopes. So let's take a look at line 1. Line 1, the points in line 1 are going to be at a -1, 5, and 2, -4. So these are our two coordinates of our first line. So this slope equation, remember, is going to be the change in y over change in x. So we're going to take the y2 minus y1, x2 minus x1. So now we're going to take our points here, 5 minus a -4. And we're going to put it over a -1 minus 2. Change our signs. This becomes a plus, and that gives us 9. This gives me a -3 at the bottom, which can reduce now to be a slope of -3. So 9 over -3 reduces to become -3. So our slope of line 1 has a slope of a -3. So now let's take a look at line 2. Line 2, the coordinates for this one are going to be a -3, +3, and then we have a -1 and a -4. So let's take again a look at our slope. We're going to take our y's, 3 minus -4, put it over our x's, which is -3 minus 1. Change our signs, gives us a +7. This gives me a -4. So this should be minus a -1. So I'll go back and change that. So minus a negative, which changes this to positive, and that gives us a -2. So this gives us a -7/2, and this one was a -3. So because our slopes are not the same, our lines are not parallel. So we can't always go by what it looks like. They appear to be parallel, but if we actually do compare the slopes, then we'll find out they're not. So line 1 is not parallel to line 2. So once again, we're using what we did in lesson 7 to find the slope. We're just going to compare the slopes now. So now let's take a look at, I want you guys to find the slope of line 3 and line 4 and determine if those are parallel. So pause your video now, work it out, and come back and check your work when you're done. All right, so if we look here, we take our coordinates for line 3, -13 and 6, and -1 and 2. Plug it into our slope equation, 6 minus 2, top minus the bottom, and we get 4, and then we do 13 minus -1, which changes it to +1. And -13 plus 1 is a -12, which is then 4 over -12 is going to reduce to -1/3. So our slope of this first one here of line 3 is going to be a -1/3. So now let's look at the slope of line 4. So 6 minus 7 is -1, 3 minus 6 is -3. That gives us a +1/3. Negative divided by negative is a positive. So because our slopes are not the same, then line 3 is not parallel to line 4. So remember, set up your points, line them up one at the other, take your y values, subtract them over your x values, and just compare the slopes. If it's the same, they're parallel. If they're not the same, it is not parallel. All right, so let's look at example 2. What is an equation of the line parallel to y equals negative 3x minus 5 that contains, or we may say passes through, negative 1, 8? Write the equation in point-slope form and in slope-intercept form. So a quick reminder of what the two forms are. We have y minus y1 equals our slope times x minus x1. This is point-slope form, and then slope-intercept is when we get rid of the parentheses and we put it into y equals mx plus b, where b is our y-intercept. So let's take our look here. The first thing I want to do is I want to identify the slope of this line, because if our line is going to be parallel to it, as we know, they have to have the same slope. So the number in front of the x that's multiplied by x is going to be a negative 3. So that means our slope is negative 3. The point that our line contains is negative 1, 8. So these are the numbers we're going to use to plug into for our x and our y, and we're going to use negative 3 as our slope. So y minus 8 equals a negative 3, x minus our x-coordinate of a negative 1, and we have to go back and change our signs, any sign that needs to be changed. So a negative 3, and this becomes x plus 1. So this right here is point-slope form. So we would be done. If it said leave it in point-slope form, this would be our result. Now, to get this in slope-intercept form, we have to get rid of the parentheses by distributing. So we get a negative 3x minus 3 equals, bring down the y minus 8. Now we got the last thing we need to do is get the 8 to the other side, so we're going to add 8. Y equals negative 3x plus 5. So this equation, y equals negative 3x plus 5, is in slope-intercept form, and it is parallel to the line that we had before, which is y equals negative 3x minus 5. So notice the difference. This is a minus 5, this is a plus 5. This will cross the y-axis at negative 5. This one will cross the y-axis at positive 5. And their slopes are going to be to rise negative 3 and run positive 1. Rise negative 3, run positive 1. All right, so now I want you to try it. So here's our equation. Y equals negative x minus 7 and a point negative 5, 3. So find the equation of the line that's going to be parallel to it in point-slope form and in slope-intercept form. So pause the video, come back and check your answer when you're done. All right, so we take our slope here, which is a negative 1, and our point is negative 5, 3. So as we plug our numbers in to our equation, point-slope form, you get y minus 3, our y value, equals a negative sign. So some people can put a negative 1 in your book, and in the homework it's just going to have a negative symbol, and it's understood 1. Parentheses x minus a negative 5. So we have to rearrange it. So we get it, change our sign, so it's y minus 3 equals negative parentheses x plus 5. That's our point slope. And now to put it to slope-intercept, we're going to distribute the negative through the parentheses to get rid of the parentheses, and you get negative x minus 5 equals, we bring down the y minus 3. So the last step is to add 3 to both sides, and y is equal to a negative x minus 2. So both of those are examples of writing equations similar to what we did yesterday, except for now we're writing equations of lines parallel to a given line. So we're using the same slope. So now let's take a look at perpendicular lines. So slopes of perpendicular lines. If two non-vertical lines are perpendicular, then the product of their slopes is negative 1. If the slopes of two lines have a product of negative 1, then the lines are perpendicular. This is our conditional statement. This is our converse, where we swap our hypothesis and conclusion. So any horizontal and vertical line are perpendicular. Okay, so that means any line that's x equals or y equals, those are horizontal and vertical lines, and they're always perpendicular to one another. Now, what it means to have a product of negative 1. A lot of you guys will get confused on this. So if I have a fraction of negative 7 over 3, in order to get this product to be equal to negative 1, I have to multiply by the reciprocal, which is going to be a 3 over 7. Now, since this one's negative, in order to have the product equal negative 1, this has to be positive. So you're always going to have to make sure you pay attention to if the sign was negative or positive to begin. because one of them has to be negative. So if we multiply this together, we get a negative 21 over positive 21, which reduces to a negative 1. Another way to look at this is it said if I went, these two cancel, the 3 cancels with the 3, we're left with 1 over 1 times the negative, which is a negative 1. So, two ways to look at that. So if I had the problem of 1/2, reciprocal of this is going to be a positive 2. The negative reciprocal will be a negative 2. Now we'll put it over 1 to help remember that it is a 2 over 1. So the 2 cancels, leaving us a product of negative 1. And the last one, let's say we have the number 5. Well, its reciprocal is going to be, this is 5 over 1, then it's going to be a negative 1 over 5. 5's cancel, 1's cancel as well, we're left with a negative 1. So all of these will equal negative 1. So the negative reciprocal is what we're going to need to find for our perpendicular slopes. So let's take a look at comparing two lines and see if they're perpendicular. So line 1 and line 2, are they perpendicular? So let's take, just like we did before, when we're seeing if two lines are parallel, we're going to compare them by doing the same operations. We're going to find the slope of line 1 and line 2. Now once again, you could count your spaces, but let's take the long route and find the coordinates. So line 1, your coordinates here are going to be at a negative 4, positive 2. And the next one is at 0 and negative 4. So the slope is going to be 2 minus a negative 4, y values over x, negative 4 minus 0. Change our sign here. We get 4 and 2 is 6 over negative 4. Now the last step is to reduce the fraction, and that 2 goes into both, so this becomes a negative 3 over 2. So we have negative 3 halves. So let's take a look at the second line, line 2. Line 2 has coordinates of, let's see, negative 5 and negative 3. And we have 4 and 3. So to find the slope, we're going to take the difference in our y's, negative 3 minus 3. This becomes negative 5 minus 4. So I get a negative 6 over a negative 9, which reduces itself to become 3 goes into both. This becomes 2, and this becomes 3. The negative signs cancel each other out, so this becomes a positive 2/3. So are these the negative reciprocal of each other? Well, if you can't see it, then take your two slopes and multiply them together. Okay, so we get negative 3 halves, and I wrote it down wrong here. The second one should be a positive 2/3. So 2 cancels with 2, 3 cancels with 3, and we're left with a negative 1. So therefore, yes, these two lines are perpendicular to one another. So you'd say line 1 is perpendicular to line 2. All right, you guys try the next one. Determine if lines 3 and 4 are perpendicular. So pause the video, come back and check your answer when you're done. All right, so once we find our coordinates here, we're going to find our slope. We get 7 plus 1 is going to give us 8, and 2 minus 3 is negative 1. Negative 8 for the first slope. Second slope is going to be a negative 1, and then over a negative 10, which reduces to 1/10. And so these two are not the same, so we say that they're not perpendicular. So they're not negative reciprocals of each other. Their product is not negative 1, so therefore they're not perpendicular. So now let's apply this to writing equations. What is an equation of a line perpendicular to y equals 1/5 x plus 2? So let's start off by identifying our slope, just like we did before. So if it was a parallel line, we'd use the same slope of 1/5. But we're going to make a line perpendicular. So it means we have to take this number, change the sign, so if it's positive here, it's negative, and now we're going to make it 5 over 1, or just 5. So negative 5 is our slope. The point, once again, is going to be 15 and negative 4. Take whatever they give us. So now we're going to put this in point slope form. So y minus -4 equals our slope of -5. And this becomes x minus 15. Change your signs. +4, -5, x minus 15. So this right here is in point slope form. Now, change it to slope intercept, which means I distribute -5x. This gives me a positive 75, y plus 4. Subtract 4. Y is equal to a -5x. This will be plus 71. All right, so this line right here has a slope that is the negative reciprocal of the first line we were given. So these two lines will be then perpendicular. So it doesn't matter what these numbers are as much. It matters as the slope. So if your slopes are negative reciprocals, then the lines are perpendicular. If the slopes are the same, then your lines are parallel. So don't get those confused. All right, so I want you guys to try the last one. The equation y equals -3x minus 5 that contains -3/7. So you're going to write an equation of a line perpendicular to it. So pause your video and do that now. All right, so the equation of this line has a slope of -1/3, which means our perpendicular slope is going to be a positive 1/3. So -3, the reciprocal of that is going to be a positive 1/3. So now we put it into point slope form. Y minus 7 equals 1/3 x minus a -3. Change our signs. Y minus 7 equals 1/3 x plus 3. Now once we got this in point slope form, next thing to do is put it in slope intercept. Distribute 1/3 x. 1/3 times 3 is going to give us 1. We're going to add the 7 to both sides, and that's going to give us 8. So y equals 1/3 x plus 8. All right, so let's take a look at the last example. Baseball field shown is on a coordinate grid with home plate at the origin. The batter hits a ground ball along the line shown. So here's him hitting the ground ball. The player who's at 110 and 70 runs along a path perpendicular to the path of the baseball. What is the equation of the line on which the player runs? So if we were to continue this line out, we'd have a better understanding of what we're looking at. So if we take this line here, extend it out, this would be the line of the ball. So this guy's going to come over and it's got to be perpendicular to it. So we got to figure out what is the slope of this line. Now, you kind of cut it off here, but you got 0, this is 20, then it's got 30, this is 40, 50, 60, 70, this is 80. Okay, so let's find the slope of this. So we want to figure out where this line crosses two places. The first one, the easiest one here, is at 0. And the other one would be right here, crosses a point. So the slope of the line right here, the ball, slope of the ball is going to be, this one here is at a positive 30. Okay, and that's the x value, and then the y value is going to be at a positive 10. So that means it's going to be a 10 and 10 over 30, which reduces down to 1/3. So let's look at this again. I think I said it wrong. All right, so if our 2 points here, one point is 0, 0, and this point right here is at 30, 10. So let's look at that. I got 30 for my x, 10 for my y. Okay, so my other coordinate would be 0 and 0, right here. So the slope would be 10 minus 0 over 30 minus 0, which gives me 10 over 30. And that's going to reduce, get rid of the zeros here, we're left with 1 over 3. Now you could think of it as 10 over 30, since all these graphs, as we start to graph here, would be every 10 units is a box. Okay, so that means that if this is 1 over 3, then our new slope, our perpendicular slope from the guy running to the ball is going to have to be a 3 over 1, but a negative. So next we want to know, what is the coordinate of this guy? Well, they gave it to us, it's at 110 and 70. So we're going to use our point of 110 and 70 to write the equation of this line of the guy has to run. So this becomes y minus 70 equals, so now I'm going to put here a negative 3. This will be x minus 110. So this equation is now in point-slope form. And if we were to change this around to slope-intercept form, distribute here, we get a negative 3x. That would give us a negative or positive 330. And we add 70. So y is equal to a negative 3x plus 400. That would be our line in slope-intercept. So always make sure you put it in the right form that they ask for. And that concludes our lesson. So remember, parallel lines have the same slope, perpendicular lines have opposite reciprocal or negative reciprocal slopes, and the product of those slopes should be -1.